Alright guys, I've been getting a lot of questions lately for some reason about stepper motors. So I made this magical golden stepper motor board so that I could just show you how to set up a stepper motor to run from your ESP32. We're using a FunBoard, but you don't have to. Okay, and then these are the two basic ways that you can set up stepper motors, and we're talking about bipolar stepper motors. This is a unipolar stepper motor, but we're using it as bipolar. I'll tell you more about that later. But we're getting to where we don't use unipolars as much anymore because we've got things like this and things like this. Now this is a quad H bridge. So essentially what it is you have some control pins right here, and we'll connect those over here, and then this output, or you can use these, or this output right here, goes to your stepper motor, and each one of these pins is a bipolar switch, so they can be a high source or low source, either any of these pins. Okay, so we'll control these pins and it'll make these pins work, right? And the big thing is, the reason why we're doing that is that you can't supply current from your ESP32 to your stepper motor. This thing can draw several amps, and that would just burn this thing right up. Plus, it uses higher voltage, so we've got a power supply over here that I've got set at 8 volts, but something like this can use 12 or 24 volts, so that's just way more than this can handle. So we run it through this quad H bridge, and I think this is an A298 quad H bridge. Okay, but basically it gives us 4 pins, and that will control the coils of the motor with those pins. Now another option is this one, and we'll set it up and run it as well. And this is a specialized chip. So this is the little board, and then this bigger thing is the carrier board. Okay, so you need to have this, which could come out. I'm not going to pull it off, and then you buy one of these carrier boards to put it on. And these are, again, your pins output to the motor. They're bipolar switches, so they can be high source or low source. And then you have these 3 pins are your inputs, and they're not. These are direct inputs. Whatever you do here, that's what happens over here. But these don't work that way. This is an enable pin, this is a direction pin, and then this is a step pin. So we'll go over that as well. Okay. So the first thing that we're going to do. Well, let's talk about this motor a second. So you'll notice that there are a lot of wires coming out of here, way more than normal. So normally on a bipolar stepper motor, you're going to have 4 wires, 2 coils. So you have a coil over here and a coil over here, and that's what, alternating the forward and reverse current on the coil, that's what makes it work. If you really want to know how it works, then I've got this other video right here about how stepper motors work. So go and check this out. And we actually build this little stepper motor out of a compass and make it work. Okay, and that's a good basics on how the bipolar stepper motor works. Okay, but anyway, I got this is a unipolar. I think it's a NEMA. I believe it's a NEMA 16 maybe. Let's see. Yeah, I don't think it's quite a 17. It must be it's bigger than a 14. I guess it's a NEMA 16. Okay, but it is a unipolar. Now the difference between bipolar and unipolar is not much. So they both have 2 coils. So in this case, the black and the brown is one coil, and the yellow and the orange is the other coil. Now what makes these different is in the center of the coil there's a tap. On the center of this coil there's a tap. Now these taps are normally connected to ground. And then what that means is that if you put one of these wires to positive, it'll go through half the coil and then to ground. If you put this one positive, it'll go through half the coil to ground. Same thing over here. And that means that you can run these wires with a transistor. You just turn it on and it runs to ground. You turn it off, you turn this one on, it runs to ground. Okay, you don't have to have a bipolar switch. But now that we have fancy chips like this and these quad H bridges are pretty inexpensive. We don't run our stepper motors in the unipolar way anymore because we have these bipolar switches. So it's just easier. So anyway, but if you want to use a unipolar as a bipolar, you can. This is one coil, this is the other coil, and you ignore the center tap grounds. Okay, so we'll just stick that out of the way, and then this will be one coil, which we'll call the the yellow and white coil, and then this will be our other coil. Will be the blue-green coil, and we'll set those things up in a minute. Okay. All right. So let's get started with this H bridge. Now, the H bridge is nice in a lot of ways. It's very simple, and you get exactly the same step distance every time you make a step. Not the case with this. Okay, but this will give you very uniform steps. Okay, where and it's very simple to think of, but it does take extra wires. You got to have 4 wires here to control this thing, whereas with this one you could do it with 2 or 3. If you don't use the enable, you could just use 2 wires, so it takes more to control it, or it takes more to control this. But you do get that more positive solid step, so depending on what you're doing, you may want to use one of these. Okay, so all we've got to do is hook up wires from here to there, and then when we control the state of these wires, it goes to here, and then it controls the state of this, and that's how we step our motor. Okay, so the only connections that we've got to do, we got to get 4 wires here, put them to there, and then we do have to have a common ground between the two. So let's set that up. So right here, let's see, here's a ground. Okay, so I'm going to find my ground pin. I'm going to use that one. Okay, and then I've got this triple wire. Now I'm going to mess the frame up while I'm plugging these in. Now on the FunBoard, I'm going to be using, let me look, I'm going to have to take my glasses off. I'm going to be using pins 5, 18, 19, and 23. So let me interrupt the frame here and I'll plug these things on. Okay, 5, 18, 19, and 23. Now those are going to be my 4 state pins, and then we're just going to take those and we'll plug them up. I'll try to right here. I can't do it on camera. Okay, so I've got those plugged up. Alright, so now the only connections that we have going are these 4 state wires. Now they're going to draw no current, okay, because the inputs to these don't draw any current, because the ESP couldn't handle that, right? So all the power is actually coming from here, from our power supply. So there's our voltage, and that's our amperage that we're drawing. Okay, so that's all of our power is coming through here, and then these are just turning it off and on, and we got the common ground. Okay, that's it. Now we got to get connected up over to here. All right, so I've got this header that fits right here, and it's got the colors we were talking about coming out of it. All right, so the way this is set up, you can just barely see it down there. It says A, B, C, and D. Well, A and B are one coil pair. C and D, the way this is set up, is another coil pair. Okay, so what we've got to do then is just plug in our wires where they match. Let's see, there's a white, and this is just a little trick. I'm using a DuPont connector and then these wires with these pins on them, because you know what, they always seem to fit together, so it works enough. Now this is a fairly low amperage motor. It's going to take less than 1 amp, so I'm perfectly fine using these little wires right here. These wires would carry 2 amps, and so everything's good using this setup. Okay, so we have one coil here, and we have it wired up, and pull that into the camera so that you got one coil there and one there, and focus is not working exactly right. Alright, get in focus. Focus, focus. Yep. Okay, so that is the only setup that we need. Now this one does have a little switch, so you got to make sure your switch is on. Okay, but that's our setup. We're going to control the states here, and it's going to change the states here, which is going to make our motor go. Now these these LEDs down here will light up according to the states right here. So we'll be able to see that. And then, so this is freewheeling right now because there's no power to it. But when we put power to it, by changing the states here, then you'll see this will lock up and just move. And this is just a paper clip that I have super glued on there, just so we can see it move easily. Okay. All right. Now let's go check out the software. So I'll minimize this, and we'll pop open, and we'll just go to Clayton's PCB shop. We'll go to MicroPython and steppers. There it is right there. So this is the software. This is a compilation of the software that I use, and I have made it available to you. So let's check out what's going on. Alright, so as it says right here, there's basically two classes. There's H-bridge, and that's for running our H-bridge, and there's A4899, which is running that special driver. Okay, so for the H-bridge, we have different modes, and these represent the states. So you can see that we're turning on one pin at a time. Now this is a full step for a single coil. Okay, we're turning on one pin at a time in a particular pattern, and that's what's making the motor move. Again, go watch that video I talked about earlier. We have a full step dual coil, so here we're turning on two coils at a time. And then this is the mode that I use most of the time, which is a half step. So what you're doing is you're turning on two coils, and then you turn one off, and then you turn on another one, and then you turn one off, and so it does half steps. So you end up with 8. You can do 8 different steps. Okay, so that is essentially your modes there. And then here's your options when you instantiate the motor. So you have to tell it what coils. Remember, we said we were going to use what? 5, 18, 19, and 23. So we'll put, this will be 5, 18, 19, and 23. Those are the pins that we're going to be using. We're going to use mode 3 is what we'll set here. We probably don't need to reverse it, but we'll look and see. I'll show you a trick for reversing things. Invert, that would be if you wanted to invert these states. You're probably not going to use that unless you're using a unipolar motor. Sleep, that says, you know, when you're done with a function, put it, set all the pins to 0 so that there's no current flowing. And that's good for heat, but it's bad for if you need to be locked in one position. So you just have to figure out whether you want to do that or not. Steps per second, okay, 200 is just a default. And then these are mins and max. They're just safety features. So let's say you don't want your motor to go, but you know, you maybe say at 1,000 steps, I'm going to be hitting the stop, so I don't want to go more than 1,000 steps. You can set that. Okay, so that's how your init feature. And then let's look at the functions. 0 just sets self.steps back to 0. Put it to sleep. Wake it up. That's just turning the power all the way off on the pins or all the way on, or to a normal state. This is a sub function. You don't use that. Here's our basic step function. So you would tell it how many steps per second. If you use none, it's the default, right? And then we can tell it if we want it to sleep at the end. And then here is beep beep, because you know stepper motors will play music. So this would, it's a way to beep and make a noise on your stepper motor. If you know, like when it comes online or something like that, you can do a beep beep. And then here's the real beep. You can tell it the frequency, how long to beep for, how long to pause afterwards, that kind of stuff. And then because we can beep, then of course we can play music. So here's a couple of little songs, and then here's the play thing where you actually put the note string, and this is borrowed from the FunBoard beeper function. So there's a lot that you can do with that, but we'll play some of that. This is just playing the notes. Okay, so that's the end of the H-bridge function, or the H-bridge class, and then we're going on to the A4899 class, and basically I just redefined some things. So you still have, you know, for a knit you got step, you got to give it your step pin, your direction pin, and your enable pin, which is, you know, because it controls things a different way. We'll talk about that later. And then you know, same stuff, and then it just redefines things that it has to. You'll see that it's using the H-bridge class as its base, and then it just redefines. It has to redefine sleep and wake because it does it a different way. It uses the enable pin. The steps are done differently, and consequently the beeps are done differently. Okay, but everything else is borrowed. All right, so that is essentially all of that. And then we have a main class that we'll use, and this is what we use to demo. So here is, we're initiating the H-bridge mode. So we've got pins 5, 18, 19, 23 like we talked about. Mode 3, and then the rest are defaults. And what are we going to do? So we're going to loop, and we'll print what the loop number is. We'll play a jingle, we'll play another one, we'll play another one, then we'll step ahead 400 steps at 800 steps per second, and then we'll step back 400 steps at 800 steps per second. We'll be back to 0, and then we'll do a beep beep at the end, and that should, you know, pretty much demo the functions. Okay, alright, so let's minimize this and open up our terminal. And just for fun, let's go ahead and make this where we can see it. So we don't need to see the ESP32, but we do want to be able to see what we've got going here, which is we'll want to see these lights, and then we want to see the motor moving. Okay, so we should be able to see that just fine. Alright, so to start out, I know, let's just get on here. So now we're on the ESP32, or check everything out. Okay, everything's fine. We're going to do Control C and then Control A, Control X. Now we're off there. And let's go ahead and load the latest download that we have. Okay, so what I'm loading is main.py and steppers.py. Alright, we're going ahead and loading that up. And it will be done in just a sec. Okay, it's done. And let's go back onto PicoCom. Now we're back at the ESP32. And let's do a Control C and a Control D. Now we'll hear the ESP32. There it goes. And then we just heard the motor. You hear that? Here, I'll maximize this. Okay, now it's a little bit hard to hear. You can see that wire vibrating. I'll push down on this. Oh, I broke my wire off. Dang. Let me put that back on. Okay, we've recovered from our catastrophe. So let's start that again. I'm going to do Control C and Control. I'm on the ESP32 and Control D. And there's the ESP. FunBoard started. Now we hear music there. Alright, do you see that vibrating? Because the way this music is created is I'm taking one step forward and one step back at a particular frequency. Okay. So we're playing a song now. I got my trusty Georgia tumbler, and watch them when I carefully take this out. Oop, almost broke it again. Alright, here we go. You should be able to hear it a little better. Oh, there we go. Making this thing. So this is making the cup vibrate so you can hear it better. There's the beep beep. Start tune. Axle F. Alright, so that's the whole setup there. Now, if you'll notice over here, watch the amperage. Now, one thing about using this is that there is no amperage control. There's no current control with this. So it will potentially, this will allow as much current as the motor will handle go through it. So when you see over here, sometimes it goes up fairly high, and I've got it at a low voltage. If I turned it up to a higher voltage, this amperage would go up, right? So it could be, you know, draw a couple of amps. So that can lead to overheating of the motors. So you have to, in some way, when you're using this, you have to in some way regulate your current, either with your power supply or a regulator in the lines or something, so that you don't oversupply your motor and cause it to overheat. One thing that you can do is make it go to sleep. So you'll notice, let's watch. Alright, see how I can move that? As long as it's not doing something, I can move it. That's because I'm making it go to sleep. If you don't have to use force to hold it in place, then you can always put it to sleep. Anyway, so that's one disadvantage of that. So there we go. Okay, so that's pretty much it for that. So now we're going to change over to this. So I think I'll turn off the video and reset everything, because it's very similar, and then just tell you what the slight differences are. Okay, one thing before I change over is I want to show you what single steps look like. So let me do this. I'm just going to tell it to step 1,000 times at 2 times a second. So we should get a step every half second. Okay. Alright, so let's look over here. Now the thing that I want you to notice is how consistent the stepping is. Every step is the same length. Okay? That's all I want to show you. That every step is moving the same amount. Alright, we'll compare that later on to the special chip, the A4899. Okay, now we have the 4988 set up. Now let's look at the difference. So from here out, it's the same. These are bipolar pins that run the motor, essentially doing the same thing as this did. There's a little bit difference. Okay, but so the setup, so this is the same thing going out, but we have to, there's really two sides to this. So here's the power side, and that supplies power to the chip that runs these outputs. Okay, so that's your 8 volts coming from over there, right? But then the controller side of this has to have 5 volts. It uses very, very little current, but it does need that 5 volts to run the controller. So this is our common ground that goes to the ESP32, and we are borrowing the 5 volt source from the ESP32. Now we can do that because the FunBoard can supply, you know, 100 milliamps, no problem, and this is using a couple of milliamps. So we can supply that 5 volts over here. So that's a difference. Now the way that this works is you have 3 pins. Let's see, this pin is the enable pin, and when that pin is low, everything works. When that pin is high, everything turns off. Okay, so it's really a disable pin, but they call it. It's enable, but it works when it's low. Okay, so that's what that pin is. And then the middle pin right here where the yellow is going is the step pin. And every time that pin gets a high pulse on it, it steps the motor 1 time. Okay, so you don't have to control the states like you did over here. You just say high pulse, step it 1 time, and it keeps track of all the states. And then this pin right here is a direction pin. So if the source is high, it goes in one direction. If the source is low, it goes in the other direction. So all you have to do is put this pin in the right state and then raise this pin for I think it's like 1 nanosecond, and then it goes back down, and it will make this motor step 1. And then if you want to turn the motor completely off, you can use the enable pin. Now a few other differences. I was mentioning earlier that this doesn't control amperage, or this one does. So on it there is a little potentiometer right here. I've just got it set to the halfway mark, okay? But what this does is control how much amperage goes out to the motor. And there is a formula, and if you go to the website here of Pololu, or however you say that, I don't know how you say that, but you can look at their documentation, and they give you a nice formula for figuring out exactly where, you know, what that resistor, that potentiometer should be. Okay, what I do is, well, right now I just have it set halfway. What I do is turn it all the way down to where it won't move the motor, and then I turn it up until I'm providing the minimum amperage for the motor to do the work that I need. And then maybe I give it a little bit more or a little bit less, but that's kind of how I adjust it. But you can also use the formula. It works okay. Okay, so that's one difference. You do have this amperage controller right here, which is nice, because then you can run a higher voltage over here, so you could run 12 or 24 volts and get more positive performance on your motor, but meaning that it could run faster because the states change faster or easier. You know, they can supply the current to change the state easier, but it won't overamp it, so that's nice. The other difference is how it actually steps. So you'll notice that there's 3 switches over here, and if you go to the website again of these where they put these little modules together, there's other places you can get them. I get them on eBay. But if you go down here, you'll see MS1, MS2, MS3, full step, half step, quarter step, 8th step, 16th step. Okay, so this works a little bit differently than what we saw with the H-bridge. So what this actually does is, let me get this minimized. What this actually does is, on a coil pair like this, instead of just doing on and off, which is what's going on over here, it's just playing on and off, this, because it has the power or the option to regulate current, it actually regulates the current. So instead of just doing on and off, it does 8 different levels of on and off. Or let me think if it's 8. Well, I can't do the math in my head, but anyway, so instead of just turning on, turning one off, it starts raising the current in this one and lowering the current in that one, and, you know, varying these things so that it gets more functional steps than you would with just the 8 that you can do with half stepping. Okay, so you really, you know, you're getting 32, I guess, or 16. Let's see, 8. What, 16, so you can go 16. Okay, so it's doing it by varying the amperage to these wires, not just on and off like this thing does. Okay, so that does have an advantage in that you can make your motor run a lot smoother. The disadvantage of that is when you're taking small steps, which we'll show you in a little bit, that some of the steps will be very big and then some of the steps will be very, very small. So if you're doing a lot of steps, it equals out, it doesn't matter. If you're trying to do really, one step at a time, you're going to get some steps that are big and some steps that are really tiny, okay, because of the way the sinusoidal form that they use for varying the current to these wires. Okay, so anyway, that's all our connections. We got 5 volts common ground, and that goes to the controller side. We have our 3 control wires, not using this one. We have our enable wire, our step wire, and our direction wire. And then we've got our state wires coming out. They're not really states anymore because they are varying amperages so that we can get multi-step. And then we've got our power. This is our motor power coming in, not our 5 volt power, but our actual motor power that goes to here coming in. That's coming straight from over there. Okay, so that's the setup. Now, let's get this to focus again. And let's hop on over. Well, actually what we need to do first is look at main. So I have commented out the H bridge, and now we're using the A4899 class. We've set up pins 18 as our step pin, 19 is our direction pin, and 5 is our enable pin. And this other stuff is just default stuff. Okay, and then we're going to run the same test sequence again. Okay, so that's what we've done there. And then let's pop open the terminal and let's get out of here. Control C, Control AX, and we're going to reload main. We don't need to reload the steppers. We'll just reload main with our new setup, right? And then we'll reconnect. And now we're connected. And I'm going to do Control C and then Control D. Let's hop over here. Here goes rebooting. And there goes the motor, which you should. Okay. Now, as far as stepping goes, this thing works similar. There's the stepping. But it's not as reliable at playing the tones. Sometimes it overdoes some and it underdoes some, and it has to do with the way that it varies those amperages. But it does, you certainly can use the beep beep part of it to acknowledge that a motor is up and online. If you really were using it to play music, you might want to use the H bridge instead of the 4899. Okay. Okay, so we've seen this work. So what I want to do now is I'm going to go back here and I'm going to Control C, and then I'm going to S.step, just like we did before. Put 1,000 in there every 2 times a second. All right, and we'll get this thing started. Now let's get back over here and look at it. Now we are on the half step mode. All right, so we see that this is running fairly consistent. Okay, see that? It's not that far off. All right, now what I'm going to do though is I'm going to come over here and I'm going to flip these switches and I'm going to put it all the way up to the 16 mode. Okay, so this is 16 steps one. Alright, now I'm going to force this back around here where we can see it. Alright, now it's actually stepping. Okay, so watch it. It's stepping, but you can't even see it moving. Now you see it moving. Okay, now you don't see it moving. So as it goes, it's following a sinusoidal curve as it's varying these amperages. And as it goes over the top and under the bottom of the sinusoidal curve, it slows down and the amperages don't change very much. And then as it goes down the slope, the amperages change a lot and you see the movement. Okay, so it's just something to be aware of, that if you're using these high stepping modes with this thing and you're trying to do single steps, you're not going to get consistent steps between, you know, from one step to the next. So that has messed me up, thinking that I would get consistent steps, and I don't. But when it's down on, let's say we put it all the way down on single step, it's not, they're not equal, but they're a lot more equal. Okay, so it's just a little thing that you need to be aware of. Alright, that just about wraps it up. You guys should be able to get started with stepper motors. You can, you know, go to the website, to the PCB shop on GitLab, and download the stepper stuff that you need, and, you know, go back and check out this video. It'll give you a lot of good stuff about how stepper motors actually are working. Okay, and then just remember that you don't want to let your ESP or your FunBoard or whatever you're using, you don't want to let this supply any current over here. So you got your power either here or here, and that's what's driving the motor. These are only driving the controllers here, and over here they're not needed. Okay, you're just, and you know, that's the main thing. Don't ever overdrive your pins on your ESP32, because you'll just burn it up, and that'll be that. Here's the last little trick. Okay, do you see which way it's going? Well, let me, here's the last trick. Well, I'll leave it running like that. I forgot to tell you guys this. If you're having trouble with your direction, you can take one coil loose, okay, and turn it around, swap the pins, and it will change the direction. Okay, see, it's going fast in the clockwise. Alright, if we swap one coil, now it's going fast in the counterclockwise direction. Okay, so all you have to do is isolate your coils. You do that with your volt ohm meter, right? Because you should have continuity between here and continuity between here. And then if you want to change your direction, you just swap one pair. It doesn't matter what pair you swap. If you swap this pair, it'll change the direction. It doesn't like that, does it? Okay, there we go. Alright, so that'll change the direction too. So just swap a coil pair and it'll change your direction. Anyway, so you guys ought to be good to go on this. Don't overheat your motor. Always keep checking it. Make sure, you know, if you can't touch it, it's probably too hot and you need to lower your amperage a little bit. Alright, well, I'm going to quit now.